Good evening, folks. My name is Jacques Duplessis, and I am here to help you with your financial mathematics tonight. Tonight, we've got an action-packed show filled with nice exam questions that are a bit challenging. So thank you for sending those questions to us. But before we start, I would also just like to thank Liberty for their generous sponsorship. Folks, without their money and their sponsorship and support for this program, it would not be possible. So a loud shout out. I'm joining Mbali. I'm giving a loud shout out to Liberty. Okay, folks, let us not waste any more time. I'm going to go to KG Moila's question. KG, it's a question that deals with a loan, the outstanding balance on a loan. So already, folks, you can see there's two big issues. Skipping payments during a loan period. So there's three issues, and then the last one is rescheduling the loan. KG, this is a beautiful question. I'm going to read it to us, and as I read it, I will make notes on the screen. It says, Tabu bought a house for $980,000. He paid a deposit of 10% of the selling price of this house. Now remember what happens to a deposit? A deposit is usually taken off the selling price, and you apply for a loan for the balance. So the purchase price minus the deposit that you paid. Okay, then he obtained a loan from a bank at an interest rate of 11% per annum compounded monthly. Now remember, there's a problem with that. If my stated period and my compounding period are different, I am not working with an effective rate per period. I'm working with a nominal rate per period. And in financial maths matrix, grade 11s, I cannot work with nominal rates. I may only work with effective rates. So we're going to tweak that just now. Okay, so he got that rate to pay the balance of the selling price. He agreed to pay monthly installments of $10,000 per month on this loan. Okay, so let's write down what we've learned. We've learned that the present value of this loan is indeed of the house, is $980,000. Then he pays a 10% deposit, so it's $98,000. That must come off the purchase price. And I mean, we can do that quite quickly, folks. You can see that that leaves you with a loan that you need to go and apply for of 882,000 Rand. It's the purchase price minus the deposit. It comes off the purchase price of this house. Okay, and that was the first question, 8.1. How much money did Thabo borrow from the bank? 882,000. Then we also saw that for the loan that he's going to take, the interest rate for the loan is 11% per annum compounded monthly. Now, folks, this is a nominal monthly rate. These two things have to be the same. So I have to tweak this. I've got to take it to the I value. So I'm going to take R, which is 11. I'm going to divide it by 12 to make the per annum per month, and to make the R an I divide by another 100. Okay, so it's 11%, or the 11 divided by 1200. Divided by 100 to make it a decimal, divided by 12 to make it effective per period. Okay, and folks, if we do that on our calculator, we will see that this gives us, now let me just get our calculator out here. We want 11, and we want to divide it by 1200. Okay, this will be what we need to work with. Now, folks, you can see if you change it to a decimal, it is 0.00916, and the sixes recur. Okay, so if I put that here, 0.00916 recurring, I really choose to work with that decimal rather than the fraction. It is always so clumsy to work with a fraction on top of a fraction. But if you're quite literate with your calculator that way, please feel free to do that. Okay, so we've doctored our rate. This is now what we're going to use in our problem. Then it says he pays monthly amount. So the monthly amount here is 10,000 Rand per month. We've already answered the first part. The second question says, how many months does it take to repay this loan? For 6 marks. How many months to repay? Okay, so that is just a normal annuity. We're paying back a loan, so your present value of your annuity formula is what you're going to apply here. Remember, your present value formula is on your formula sheet. It's x, 1 minus 1 plus I to the minus n over I. That is the formula that we need to apply here. So our present value for our loan is 882,000. We're making monthly payments of 10,000 Rand, and we have 1 minus 1,00916 recurring divided by 0,00916 recurring. Now, folks, the power here is what we are looking for. Let me write it in blue. We are after that power of minus n. That is how long it will take Tabu to pay off his loan. Now remember that n is in the power, kg. So to get it out of the power, you need to apply log laws. Let's see, how do we get this by itself? Well, first of all, we will divide by 10,000, both sides. Okay, so we're going to end up with 882,000 divided by the 10,000. Okay, then I'm going to multiply this across. Remember, this is now here. This I'm going to multiply across 0,00916 recurring. And then what's left on the other side is the top of this formula. So this 1 is going to become a minus 1. And that is going to equal minus 1,00916 recurring to the power of minus n. Now, folks, all of this here is calculator work. It's going to take me a bit of time to do this calculator work. So I'm going to suggest that I give you that answer and then we look at the process going forward. You can work this out step by step on your calculator. So let's go and let's see what this becomes. This whole calculation that's over here becomes 0 minus 0,1915. This whole side. That is equal to minus 1,00916 to the minus n, and as per usual, my minuses become pluses on both sides, and this is where I go into the next phase of the problem. There's two different bases. The one base is 0,195. The base on the other side is 1,00916 recurring. There's no way that we can get those two to look like each other. So we're going to employ logs. Okay, so our very next step, I'm going to do it in another color. Minus n will then be the log of 0,1915 divided by the log of 1,00916. Now, if you remember this 6 recurs. So when you're on your calculator, you're going to fill your screen with the 6s like we did when we calculated it on our calculator here, 11 divided by 1200. So just fill your calculator screen with 6s and then do this calculation. You will see that minus n becomes, let me make space here for us, minus n then becomes minus 181,137,9918. Now, folks, Again, the two negatives cancel one another out. So I want to focus on that answer. Don't be tempted because there's this 0.13 to go down to 181, folks. That's not correct, KG. I hope you're listening. Okay. We have to go, that 1,1379918 is an indication to you that the loan has not been paid off. It's not fully amortized. There's a last payment that has to happen, which is going to be less than the 10,000. So if we want to write our answer down, therefore, N is equal to 182 payments left. What are they made up? 181 at 10,000 each, and then the payment 182 is the payment that is going to be less than the 10,000. That's what the decimal portion is telling you. You can also not take the 182nd payment to be 10,000 because it's not. It's less than 10,000. Else the result would have been 182. Let's see the next part of this question. Calculate this balance on this loan immediately after the 90th installment. Now, folks, this is tricky. There's two ways to find your outstanding balance. The first one is to simply just say it is the present value. Let me write that down. Your first option is the outstanding balance is the present value of all the unpaid payments. So in other words, we would say if all of these payments were equal, we would simply just take 182, subtract 90 from it, and that will leave us with 92 payments that's left to still be made. So we want their present value. But in this case, the payments aren't equal. So we're not going to use this definition for outstanding balance. We are going to do the following. We want the outstanding balance, I'm going to draw a timeline here, at point 90. Timeline 90. This is what we're looking for. Now, all over here, there was payments of 10,000. So I'm just going to put 10K, 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 and we had 885 as our present value. So what do we know? We know that the 10,000 payments were definitely made. And folks, this is the golden rule of the timeline. Please don't forget this. Make a note. You have to converge to the same point on the timeline. Okay, very important issue when you work with timelines. Okay, so where our previous method would have brought everything back to 90, we are going to move everything forward to 90 because we know there's a definite 90 payments of 10,000K was made. Okay, so this is what's going to happen in theory. We're going to take this forward by normal compound interest, and then we're going to find the sum of the annuity if we take all of these payments to the same place, which lies over there. Okay, so we're going to say, let me just move up a little bit. Our outstanding balance at 90 is going to be this 885, 000, going forward 1,00916 recurring for 90 payments, okay, because we want the outstanding balance at 90. And with that, now that, what does that do? That takes the price of the loan or the value of the loan, the value of the loan at timeline 90. From that, we've been paying off 10,000 per month. So we're going to subtract 10,000 in our annuity formula going forward. So 1,00916 recurring. There was 90 of those payments minus 1 divided by 0,00916 recurring. Now, the second half is the annuity payments that moved to 90. The first half of this calculation on my screen is just the value of the loan moving to the same point on the timeline. We cannot leave the value at the beginning and take that and subtract to the 10,000s that happened over a 90-month period. Okay, folks, now all of this is beautiful calculator work for you to do. Once you've done it, you get 615,991,70 as your result for your outstanding balance at 0.90 on this timeline. Now, we can round it up to the nearest rand, so we can go 165,992 if we want to, but then we just say approximately equal to that. Let's look at the next calculation that they ask us for. They say, calculate, Thabo then experienced financial difficulties. So Thabo got into problems here, so our timeline is not over. Let's show what happened. He could not pay the next few payments. In fact, he paid, the last payment was here. He did not make 91, 92, 93, 94, 95. The first payment again happened at timeline 96. So here's a quick lesson on what the bank is going to do. The bank is going to say to him, okay, Tata, we understand you're in problem. You've got problems now. COVID-19 happened. Let's give you 5 months break here. Okay. So what do? They say, this is our outstanding balance, but they're going to charge you interest for 5 months. Why not 6 months, folks? Because for 5 months, you did not pay. You pay at the end of the 5th month, which is at timeline 96. So this didn't happen, this didn't, this, so there's a deferment here of 5 periods. Okay? So for 5 interest periods, listen to my language. I'm saying it's 5 interest periods. So the interest periods in this problem is given as months. Okay, so let's have a look. So our outstanding balance will now move forward to timeline 95, a month before the payments started. So this will be 615,991,70 going forward, just normal compound interest. Remember to fill your screen with 6s. You raise it to the power of 5 and you get your new outstanding balance on this loan. Okay, remember, outstanding balance at 90 was calculated for 5 months. Nothing happened. 5 months interest period. So the loan value is going to be different. Our loan value now is going to be 644,747,34. You can see the difference here. Okay, it's close to a 30,000 rand was added in interest for that period where nothing happened. Now that is the new present value of this loan. Now the problem says to us here, Thabo experienced a difficulty, couldn't pay. He paid at the end of the 96th month, but he increased his monthly installment. So, this, we call it a fixed payment annuity or a fixed period annuity. What's happening here? The payment is not staying fixed. It's not going to be 10,000, it's going to be more. So the period is fixed. He says he wants to pay off the loan in the same time interval as was planned initially. Okay, so let's see how that works. If I now want to pay the loan off this here, this is the third part of it. This is the present value of the loan. 747,34. The payment is going to change. 1 minus 1,00916 recurring. We'll work out the power now over 0,00916. Now my power for my bracket from 95 to the end of this timeline, which is, or the end of this period, which is 182 periods, is 87 periods left. Okay, so this has to happen in a total of 87 periods he now has. So remember here, the period remained invariant. That is just a fancy word for saying the period didn't change. Okay? Period stays the same, so his monthly payment has to go up. Okay, so we can put this into our calculator, turn it around, multiply it with the other side. So what I'm trying to say, this is just calculator work that you are very, very familiar with, and your new monthly payment becomes 10,786 Rand and 85 cents is what Tabo's got to pay to amortize this loan. Remember, amortize means paid off with interest. Okay, so that was a beautiful question, KG. It dealt with a loan, it dealt with skipping payments, with outstanding balance, and then with a fixed period annuity right at the end of that problem. Please make sure, folks, if you use timelines, that you keep the golden rule of the timeline, and that is that you must converge onto the same place at the timeline.